So today we're starting our last topic with our trig graphs, and it's on inverses. So we're going to spend 2 days on this. The first day we're just going to talk about the numerical meaning and values of inverses, and then tomorrow we will be talking about the graphs. So something that I stressed from the first couple days of this unit is in trig, and last unit, in trigonometry, reciprocal functions and inverse functions are not the same. I proved that to you in the last unit by having you, for example, take cosine inverse of 1/2 and then secant of 1/2, and you get completely different answers. Now, we know what secant and cosecant look like, for example, in cotangent, all right? And you're going to see that tomorrow that tan inverse and sine inverse and cosine inverse look nothing like secant, cosecant, and cotangent. So another reason why they are completely different functions. Okay, so today we're just going to focus on the numerical values, and then tomorrow we will look at the graphs to understand why certain things are happening with the numerical values. So remember, you used inverses in geometry, and we know inverses are used to find angles in trig. So we know, for example, in cosine of theta is 1/2. So if I cosine inverse both sides, we know that a function and its inverse reduce. What I'm asking here is, at what angle is 1/2? Okay, at what angle, cosine of what angle is 1/2? So this is why I've really emphasized to you to know the ratios. And so if you were doing this in geometry, you would tell me that theta is 60 degrees, or now you know that it is pi over 3. Okay, now sine of theta is 1/2. So if we did sine inverse, we would get, we're asking the sine of what angle is 1/2, and that would be 30 degrees or pi over 6. All right, so when we're thinking of inverses, we have to think like we're working backwards. Okay, next one. Tangent, nope, I did not want that. I wanted tangent of theta is 1. So I would tan inverse both sides, and I am asking you tangent of what angle is 1, and we know then that tangent of 45 or pi over 4 is 1. Okay, one more. This is all review from geometry. So if I said cosine of theta is square root of 3 over 2, if I'm solving for theta, I would take cosine inverse. And I know where cosine of what angle is square root of 3 over 2. That is 30 degrees or pi over 6. So another reason we do the graphs besides knowing them is getting to know those ratios. We got to know the ratios. Now, oops, I forgot this one. Sine of theta is square root of 3 over 2. So if I sine inverse both sides, I am asking you the sine of what angle is square root of 3 over 2. And that would be 60 degrees or pi over 3. Okay, so now we know that this is what you did in geometry, but we know that in geometry you only worked with angles between 0 and 180. And we know in trig we have negative angles, we have angles bigger than 180. We have angles that go to infinity. And we saw that when we were doing our trig graphs, because we often had cycles that went past 2 pi or past negative 2 pi. So what we have to think about here is, when we're answering these, we really need to think about angles between 0 and 2 pi, because we have our unit circle. Okay? And so let's go back to some of these questions we did at the beginning. All right? So we're not just going to look at angles between 0 and 180 like you did in geometry. I just did that to start with so that you reviewed inverses, okay? But now we know that we are dealing with the unit circle, and technically we know that answers to this, if I were talking about angles that went to infinity and negative infinity, I would have an infinite amount of answers. But our focus is going to be finding angles between 0 and 2 pi. So I want to go back to this example here. Cosine of theta is 1/2. All right, so we know if I cosine inverse both sides, I would ask myself the cosine of what angle is 1/2, and we should know that that's 60 degrees or pi over 3. Okay, now I also want you to go back to all students take calculus. Isn't cosine positive in quadrants 1 and quadrants 4? So isn't there another angle in quadrant 4 that the cosine of that angle is 1/2? So if we have to, we could draw out our unit circle, but wouldn't it be the reference angle in quadrant 4, or an angle in quadrant 4 that uses 60 as a reference? So wouldn't that be 300 degrees or 5 pi over 3? Okay, so what I want you to do right now is, if you need to pause it, I want you to take out your calculator. And take out your calculator, and for right now, let's just put it in the degree mode. Okay, I want you to put in the cosine of 60, and that should give you 1/2. Now I want you to put in the cosine of 300, and that also gives you 1/2. All right, now I want you to put in your calculator the cosine inverse of 1/2. And if you're in the degree mode, it's only giving you the answer of 60 degrees. Why doesn't it give you the answer of 300? Well, that is another topic that we're going to talk about, but it is based on principal values and based on the inverse graph. So, not throwing too much at you at one day, we will talk about tomorrow why the calculator only gave me an answer in quadrant 1, but we know we actually have 2 answers, one from quadrant 1 and one from quadrant 4, because cosine's positive in quadrant 1 and quadrant 4. Okay, let's do another one. Sine of theta is 1/2. So if I do theta is sine inverse of 1/2. Where is sine equal to 1/2? Okay, well that would be at 30 degrees or pi over 6. All right, now we also know that sine is positive in quadrant 2. So what other angle uses 30 as a reference and is in quadrant 2? That would be 150 or 5 pi over 6. Okay, so now what I want you to do with your calculator is, I want you to put in sine of 30, and that should give you 1/2. And I want you to put in sine of 150, and that should give you 1/2. Okay, now I want you to put in sine inverse of 1/2. And if you're in the degree mode, it only gave you 30 degrees. Should you have both of these answers if I asked you that? Yes, you should. Why does your calculator only give you 30 degrees and not 150? That is based on the inverse graph, which we will talk about tomorrow. So twofold here. I want you to understand that when I'm asking you to find angles, we're talking about angles between 0 and 2 pi. All right? I'm also asking you, or not wanting you to notice, that your calculator does not give you all the answers because of the inverse graph. Now, I will explain that tomorrow when we talk about the inverse graph. Okay, so now let's take a look at this one. Tangent of theta equals -1. Okay, so theta equals tan inverse of -1. Well, first of all, when I'm dealing with inverses, I don't worry about the negative at first. I just think of where is tangent equal to 1? That is 45 degrees. However, where is tangent negative? It's negative in quadrants 2 and 4. So what angles in quadrants 2 and 4 use 45 as a reference? Well, that would be 135, which is 3 pi over 4, and that would be 315, which is 7 pi over 4. Now, I want you to put, tan inverse on your calculator of -1. And it gave you -45. Well, -45 is coterminal with 315. So tomorrow, when we talk about the trig inverse graphs, we're going to see why it didn't give me this answer from quadrant 2. It did give me this answer in quadrant 4, but why didn't it give it to me as a negative angle? Okay, let's do a couple more. So, cosine theta of square root of 3 over 2. So, again, this is why we've got to know our ratios. So, cosine inverse of square root of 3 over 2. Where is cosine square root of 3 over 2? Okay, that is in quadrant, that's quadrant 1, and that would be 30 degrees or pi over 3. Cosine is also positive in quadrant 4. So what uses, that would be pi over 6, sorry. What uses 30 degrees as a reference in quadrant 4? That would be 330 or 11 pi over 6. Okay, so now, last one of these. Sine of theta equals negative square root of 3 over 2. So I'm solving for theta, so I need sine inverse of negative square root of 3 over 2. If I were you, I would ignore the negative sign and just ask myself, where is sine square root of 3 over 2? Okay, that is at pi over 6. I'm sorry. That is at pi over 3 or 60 degrees. However, where is sine negative? It's negative in quadrants 3 and 4. So, what angle in quadrant 3 uses 60 as a reference? Well, that would be 240 or 4 pi over 3. What angle in quadrant 4 uses 60 as a reference? That would be 300 or 5 pi over 3. So, when we're asking to find angles, I don't care what the directions are, we're always finding angles between 0 and 2 pi. So, we have to think about all students take calculus. And you can use your calculator at first, but I encourage you maybe just to draw out your triangles because as you can see, knowing these ratios never goes away. We've got to know the ratios. So when we're thinking of inverses, we got to think backwards. But we also have to think about all students take calculus. If the ratio is positive, I got to look for where the ratio is positive in which quadrants. If it's negative, I got to find the angles where the quadrants where it's negative. Now, again, the idea that I talked about principal values, there's a reason your calculator does not give you all the answers. It's because the inverses restrict our domains and ranges, and we will talk about that with our graphs. Okay, so just to kind of give you a heads up here, if I had my sine inverse graph, which I don't expect you to understand this yet, but when I'm talking about domain restrictions, I'm talking about that sine inverse is restricted between quadrants 1 and quadrants 4. It's only going to give me answers in my calculator from one of those quadrants. Cosine inverse is restricted to quadrants 1 and 2. It's only going to give me calculator answers either from quadrant 1 or quadrant 2. Tangent is restricted between 1 and 4. So I don't expect you to understand that at this point without seeing the graph. However, I just want to mention that when you're using your calculator, if you do, there's going to be a reason that your calculator, for example, when I have a negative sign, it's only going to give me an answer in quadrant 4. When I have a negative value for cosine, it's only going to give me an answer in quadrant 2 and not quadrant 3. Okay, so here is problems that I want you to be able to do here. We're going to skip around. Oops, I erased this. I want to do this one. If I asked you to find the cosine of the sine inverse, let me just rewrite that. We're going to skip those. We kind of have already done that. No, actually, I'm not going to skip those. Okay, so if I asked you to find angles between 0 and 2 pi, so sine inverse of 1. So it could be written like this, sine inverse of 1. Where is sine equal to 1? Well, in this case, it's a quadrantal angle, and the only answer is pi over 2. Okay, cosine inverse of 0. Where is cosine equal to 0? Well, your calculator would give you an answer of pi over 2, or 90 degrees, but it's also 0 at 3 pi over 2. Okay? All right. I want to do a problem like this. What if I asked you to find cosine of the sine inverse of 1/2? Okay, these are not inverses of each other, so they don't reduce. So we have to work our way from the inside to the outside. Now, this is like a simplified problem. I'm not asking you to find angles. I'm just asking you to simplify this. So where is the sine 1/2? That is at 30 degrees. What's the cosine of 30 degrees? Square root of 3 over 2. So if you're like, well, Mrs. Evans, why don't we consider 150? It's kind of like a square root problem. If I asked you for the square root of 9, you would tell me 3. But if you were solving an equation, x squared equals 9, you would tell me plus or minus 3. So in problems where I'm asking you to find all angles, you're going to list all angles. But if you have a problem that you just simplify, you just give me the principal value answer or the first answer. Okay, so let's do one more of those. Let's do sine of tan inverse of 1. So let's work our way from the inside to the outside. Where is tangent equal to 1? That is at 45 degrees. What is the sine of 45 degrees? That is 1 over the square root of 2, or square root of 2 over 2. So again, I can't emphasize enough to you to know your ratios. All right, something else I'm going to mention very quickly here is we've got also some synonyms, or if you see the words arcsine, arccosine, arctangent, that is another way to name inverses. So one of the reasons they do that is just because people get mixed up with reciprocals and inverses. So this is a way to distinguish we're talking about inverses here. Now, I would like you to take out your calculator because not everything is a nice angle like we've had in the past. Examples. So if I have arc sine of 0.362, go ahead and put sine inverse of 0.362. Fortunately, I don't have my calculator with me. Now, that is going to give me an angle in quadrant 1. That would be one of the answers. But, so whatever angle that is, now, shouldn't I have another answer from quadrant 2 because isn't sine positive in quadrant 2? So I would need to find the angle in quadrant 2 that uses this as a reference. Okay, so you should have 2 answers here. All right, now tan inverse of negative 12.5. If you put that on your calculator, again, I encourage you just to be in degree mode. You can always convert these to radians. But if you're using your calculator on not so common angles, you're not going to recognize the angle if your calculator is in radians. You can always convert your answer. So if you're in degree mode, I want you to find tan inverse of negative 12.5. Okay, so that is going to give you an answer in quadrant 4. Okay, but now where else is tangent negative? It's negative in quadrant 2 as well. So you will have to find the reference angle in quadrant 2 and find the angle in quadrant 2 that has that same value. Okay, so lots of information there, but sine inverse means we're working backwards and we're looking for angles. We are looking for angles between 0 and 2 pi. Calculator doesn't give us all of the answers because of a term called principal values. It restricts the answers because of the graphs, which we will talk about tomorrow.